Welcome everyone to our lesson on conditional statements. This is section 2.2 from the book, and we're continuing to learn about reasoning in geometry, right, and in math in general. And so this lesson with conditional statements is really helping us to understand the structure of a statement and then how to determine the truth value of a statement. And also, some different ways that we can rearrange a statement to evaluate truth value. So a conditional statement in itself is an if-then statement. So that's basically what it is. And sometimes you won't necessarily see the if and the then, but it's a statement that has a premise and then kind of a conclusion or result. And so the premise is what we call the hypothesis. That's the if part of the conditional statement. Okay, so the hypothesis is the part following the if, and the conclusion is the then part of a statement. Okay, so it's the part that follows the then. So if I have a statement like, if it is cloudy, then it will rain, like this one down here, then I'm not claiming that this statement is true nor false. I'm just suggesting a conditional statement here. So if it is cloudy, then it will rain. I can break this down to the hypothesis, right, which is the part that comes after the if, and the conclusion, which is the part that comes after the then. All right, and so that's just to give you an example of the hypothesis and conclusion of a conditional statement. All right, now just wanted to also introduce some symbols that we can use to represent a conditional statement. So in this situation, we have P arrow Q, and that arrow basically denotes that there's a condition going on, right? That this is actually if P, then Q. And so you can read it like that, or you can say that P implies Q. All right, and so P in this case would be the hypothesis, and Q would be the conclusion. All right, so the first type of exercise that we'll see is just to identify the hypothesis and conclusion of each statement. So number one, we have an if-then statement. If a number is even, then it's divisible by 2. And so once again, we're not trying to determine whether this is true or false. We're just trying to identify the hypothesis and the conclusion. All right, so remember, the hypothesis is the if part, and the conclusion is the then part. All right, and so number one, if a number is even, so whatever follows the if and comes before the then, right, is the hypothesis. Okay, so that's the hypothesis. And then it is divisible by 2 is the conclusion. All right, number 2, if you live in Miami, then you live in Florida. So the hypothesis comes after the if. So you live in Miami is the hypothesis. And the conclusion is you live in Florida, because that comes after the then. All right, so try number 3 on your own. All right, so number 4 is a little tricky. We mentioned earlier that sometimes a conditional statement you don't see an if nor a then. And so number 4 is a situation like that. It says adjacent angles share a side. So what's the premise there? Well, let's try to rewrite this. So we can say, well, if angles are adjacent, right, that's basically the premise, then they share a side. Okay, so the hypothesis would be angles are adjacent, right? And the conclusion would be they share a side. Oops. Conclusion is what I meant to write. All right. Okay, so now here at the end we can see which of the above statements are true and which are false, right? So, so that's something we can evaluate apart from identifying the hypothesis and conclusion. And so number 1, if a number is even, then is divisible by 2. Yeah, that's true, right? Because every number that's even would be divisible by 2 because every even number is a multiple of 2, right? Number 2, if you live in Miami, then you live in Florida. Can you think of a counterexample there? So what if you lived in Miami, Ohio? Then you don't live in Florida, right? So you could live in Miami, New Mexico. I'm not sure if there there is such a thing, but that would prove the conditional false, right? Or the statement false. All right. Number 3, if a number is divisible by 5, then it's odd. I'll let you tackle that one. And adjacent angles share a side. Yeah, that's true by definition, right? Adjacent angles do share a side. So, okay. All right, so number 2 is false. And 1 and 4 were true.